This is an annuities example from Unit 3, topic 9 from the homework. So here we have, how much do you need to invest every month to reach a savings goal of $600,000 at the end of 20 years if you invest an annuity that pays 3% interest compounded monthly? So let's keep a couple things in mind. That means that we are investing for 20 years, 12 times a year because it's monthly. We have an interest rate of 3%, which is 0.03, and we want to have $600,000 at the end of it. This is a great way to think about like retirement savings, or just like look at your goals and look at how much you need to invest every month to reach your goals. So the first thing we need to do is get the right formula. So this, what we're going to need is our annuities formula with time. So here we have A of T equals this really long, we have D, which is that investment amount that we're looking for. And we have 1 plus R over N, that's the rate over the number of times we're investing every month, or excuse me, every year, so it's going to be 12. All to the N times T power minus 1, all of this divided by R divided by N. So let's go ahead and identify some of the stuff that we got from our problem. So we know that A of T equals 600,000. This we know is the amount that we want here at the end. All right, so we have T is equal to 20 for 20 years, that's the time. N is the number of times we're investing in each of those terms, so we have 12 months, that's for monthly. R is 3%, oops, 3%, but that's actually equal to 0.03. And that's everything we need. What we need to solve for is D. We need to figure out that investment amount. So the easiest way to do this is to plug in all those numbers into this long, hideous formula and then solve for D. So we're going to start with 600,000 is going to equal, again, we have D. We have 1 plus, so our R, that rate was 0.03 over 12. And we're going to put parentheses around those. And we're going to raise that to the N times T power, which is 20 times 12, minus 1, all over the rate, 0.03 divided by 12. All right, so that again, just going back to our formula, that was this formula and just plugging in all of our known values here. All right, let's start reducing a little bit of this. So we're going to start here. We're going to say D. And one of the things it says it's important to remember, it says, do not round until you have calculated the final answer. That's important because if you start rounding at the tenths or the hundredths place, when you get, like, for example, this decimal right here or this decimal right here, you're going to get a different answer. So you have to be real careful with that. So let's start with, first, let's do 0.03 divided by 12. So 0.03 divided by 12 is going to give us 0.0025. So here we have 1 plus 0.0025, and then let's do 20 times 12, and that's going to give us, over here's 240. Oops, let me make sure you guys can see that. 240 minus 1 all over, and let's do that 0.03 divided by 12. That's going to be, oh, we already did that, sorry, 0.0025. There we go. All right, so let's go ahead and keep reducing this. So, and I'm just going to write that for now. So we have D times, so now we have 1.0025 to the 240th power minus 1.0025. So when we do that in the calculator, we're going to do 1.0025 to the 240. It's going to get us that number. Now, I'm going to write down a number, but what I'm going to be doing too is saving these in my calculator. Here I'm doing this on this free calculator, and you can click up and copy and paste that down, but it will round. You're probably fine just copy and paste that. So I'll show you how I would do it on the online one. In the free one, you could just go up and highlight it if you have a graphing calculator. So just make sure to maintain those decimals. All right, let's see where we left off. So we have that number. So we need to write this 600,000 equals, so we have D times, so we have this number, 1.82, I'm just going to write 821 for now, but again, I'm not rounding it, I'm just writing it rounded for the fact that I can only fit so much on this paper. Minus 1 all over 0.0025. Now we have D times 0.8221 divided by 0.0025. So now we have a number. It's a little bit easier to work with. So the first thing we need to do is multiply both sides by 0.0025, right? Oops. So we're going to multiply, 0.0025 on both sides. So when we do that over here, we have 600,000 by 0.0025. We're going to end up with 1,500 on this side. These cancel each other, so now we have D times 0.821. We're going to divide both sides by 0.821, and we're going to maintain that decimal for a little bit longer. So then these are going to cancel, and we're going to end up with D equals, and let's come over here. So now we have 1,500 divided by, and I'm going to go ahead and just copy and paste this down. Oops, hold on. I'm so sorry. Should have done that 1 point. Let me do this again. We're going to do, because I forgot this was before we subtracted 1. So we just want the 0.821. So we're going to say 1,500 divided by, and we're only going to copy and paste this part. That was a mistake. Again, we didn't want that 1 in front. All right, now that tells us that D equals 1827.59. That's our final answer. Now let's go see where we needed to round this. So it says round your answer to the nearest dollar. Remember, this makes this round up. So we would say that our final answer is 1828. And it says do not put a dollar sign in your answer. So I think I said that in the actual problem where you input it. So in this example, our final answer would be 1828. So that's how you do this type of annuities problem. If you have any questions about that or anything else, let me know.